This is the Math 2 Chapter 10 review. We'll start with number 1. We need to complete each equation. We have 3 to the second times 3 to some power equals 3 to the 10th. Well, I'm going to add the exponents when they're over here because the rule tells us if we have a to the m times a to the n, it's a to the m plus n. So we're just going to add. 2 plus what is 10? Well, 2 plus 8 is 10, so we'd have 3 to the 8th. Number 2, same idea. A to the 6th times a to some power equals a to the 8th. 6 plus 2 equals 8. For number 3, that's the same idea as number 1 and 2, but now we have multiple variables. X to the second, x to some power, x to the 5th. 2 plus 3 is 5. And then y to the 5th, y to some power equals 11. 5 plus 6 equals 11. So we'd have x to the 3rd, y to the 6th here. For number 4, we have a to the 1/2 times a to some power equals a to the 1st. Now it's really tempting here just to want to multiply and think, oh, I'll do 1/2 times 2, multiply and get 1. Not the case. What do we add to 1/2 to get 1? We would add 1/2. Number 5, we have x to the 2/3 times some power equals x to the 11/12. Now I want it to be in terms of denominator being 12, so I could do 2/3 and make that 8/12 plus some power equal, or some exponent equals 11/12. Well, I can see I need 3 more, so I need 3/12, which is 1/4, which would be my answer. On number 6, I have m to the 3/4 plus something equals 5/4. So that's 3/4 plus a blank equals 5/4. That blank is going to be 2/4 or 1/2. So I'll put 1/2 right there. Then I have n to the 1/2 plus something equals n to the 1st. Just like number 4, that is also going to be a 1/2. 1/2 plus 1/2 is 1. Looking down at number 7 through 12, we're going to be simplifying. So, same as before, I have a coefficient now in front, so I'm going to make that 2d to the 5th because I have 5 d's. Number 8, that's going to be x to the 7th, x to the 3rd plus x to the 3 plus 4. Number 9, I have x to the 3rd and x to the 1st, so that gives me x to the 4th. And then y to the 5th, a negative y to the 7th. I'm going to put a negative out in front, and that's going to be a y to the 12th. So our answer is negative x to the 4th, y to the 12th. Number 10, we have s to the 3/5 and s to the 2/3. I'm going to have to add. So I'm going to do s to the 3/5 plus 2/3. I want them to have common denominators, so they're going to have a denominator of 15. So I'm going to multiply the top and the bottom by 3 here. That gives me 9. And then the top and the bottom by 5 on this fraction, that gives me 10. So I have 19/15. So my answer is S to the 19/15. For number 11, I have, let's go over here. Number 11. We have p to the 1/3 plus p to the, or times p to the 1st, and q to the 1st times q to the 1/2. Well, if I'm looking at 1 plus 1/3, I can just make this 3/3, and I have 4/3. And then q to the 1st would just be 2/2, so that gives me 3/2. So my answer is p to the 4/3 q to the 3/2. Number 12, we're going to do 2 times 3 is 6. Then I have m to the 3/4 plus 1/4 is 1, so it's just m. And n squared, n to the 1st, that'd be n to the 3rd. For number 13, we have 5x to the 2/3 inside the exponent to the 3rd. So we're going to go 5 to the 3rd, x to the 2/3 times 3, because it's an exponent to an exponent, it's a power to a power. This becomes 125 here. 2/3 times 3 is 6/3, and that actually comes out to be x squared. Now looking at 14. Here we have an exponent to an exponent. So when we have a to the m to the n, we're going to say that's a to the m times n. Now that's different than the one we've already talked about. When it's two separate bases, we add the exponents. In this one, when it's an exponent to an exponent, we multiply. So we're saying here, if we called this x, we're saying 5 times x equals 15. Well, we need x to be 3, so our answer is 3. So 5 to the 5th to the 3rd is 5 to the 15th. For number 15, negative 4 times what is 20? That's going to be negative 5. For 16, I have 4x to the 3rd and y to the 5th is inside that exponent. And if I look over here, I get 16, x to the 6th, y to the 10th. Well, 4 is now 16, so that was squared. X to the 3rd is now x to the 6th, so that 3 was multiplied by 2. Same with the 5 to the 10. Looks like we're going to square it and put a 2 there. For 17, 2/3 times what equals 2? Well, 2/3 times some value equals 2. We can kind of look at it a couple ways. One of them is if we know about multiplying fractions, and when you multiply a fraction by its denominator, by the value in the denominator, it clears it out. So if I multiplied by 3 here, 2/3 times 3 would leave us with just 2. So that would be an answer. That's how we could get 3 right there. Another way we could do this is do 2/3 times our box equals 2. I could divide the 2/3 to the other side, and then it makes it 2 times 3 over 2. In that case, also becomes 3. So our answer is 3 either way. On 18, I have 1/2 times what equals 1/4. If we write this one out, 1/2 times what equals 1/4. Knowing fraction multiplication, I do 1 times what equals 1. That's 1. 2 times what equals 4. That's 2. So we're going to put a 1/2 right here. And then for 19, this is similar to number 16. I did 2 to some exponent gives me 4. That's going to be squared. X squared times 2 is 4. Y to the 1/4 times 2 is 1/2. So we want to put a 2 right there. In number 20, we have two different terms. So the 4 is going to be multiplied to the 3, and the exponent on the r, which is 1. So we're going to get q to the 12th, r to the 4th. 21, I'm going to distribute the exponent first. I have 1.34 to the 10th and 1.34 to the negative 8th. Together, 10 and negative 8, I have two 1.34s, so I'll write 1.34 squared. In 22, I'm going to distribute the exponents in first. I have 12 to the 5th, x to the 10th, y to the negative 10, 4 to the negative 7th. Well, before I take that, if I have a negative exponent, I could put the whole thing underneath the fraction to make it a positive exponent. So now it's 4 to the 7th, x to the 7th, y to the negative. It's positive. And then y to the negative 21. Now I'll take care of the 12 to the 5th and the 4 to the 7th in a minute. But before I do that, let's simplify some of this. I have x to the 10th over x to the 7th. So that's going to end up with an x to the 3rd on top. When it's division, we can do subtraction. So 10 minus 7 gives us 3, so we put x to the 3rd. But another way to think of it as which one has more? The top has 3 more, so it'd be x to the 3rd. I have negative 10 minus a negative 21. That's negative 10 plus 21. I'm going to have a y to the 11th on top there. Now we could look at simplifying this down a little bit more, and a way we could do that is 12 to the 5th is actually 4 to the 5th times 3 to the 5th. So I could take out 5 of the 4's out of this, and that leaves me with 3 to the 5th on top, 4 squared on bottom, x to the third, y to the 11th. We can multiply out from there if needed. 3 to the 5th is 243. X to the third, y to the 11th over 16. And then again, this number 22. In 23, I'm going to distribute, and I get negative 2 squared is 4. Then I get r to the negative 8. Then that's going to be, take the negative fraction, make it positive, put them underneath, I get negative 3, r squared, z to the 8th. Now we look to simplify. If I took this negative 8 and moved it to the bottom, that's going to make it r to the 10th, z to the 8th. And we could have our answer as 4 over negative 3 r to the 10th, z to the 8th. For 24, I'm going to multiply. I have x to the 4/7 times 7. If I multiply a fraction by its denominator value, I'm left with the numerator, so it becomes x to the 4th. For 25, I'm going to distribute the exponent. I get 3/4 times 4 for A and 7/8 times 4 for B. So for A, I'm going to be left with 3, because 3/4 times 4 is 3. B, if you don't see it, you can make it 28 over 8, which is eventually going to be 14 over 4 or 7 over 2. So you could write A to the third, B to the 7 over 2. For 26, we're going to simplify with our division. I have 3 more w's on the bottom, so I'll write as 1 over w to the third. 27, I can reduce 21 over 3, leaves me with a 7 on top. And if I look here, I have 3 minus negative 1, which is 3 plus 1, so that's going to be x to the 4th, so it's actually just 7x to the 4th. 28, I'm going to distribute in the exponent. I get n to the 35th and v to the 21st. For 29, since I have a negative exponent, I'm going to flip them first and write it as 3c to the third over e. Let's actually flip them first. I'm going to write them as e to the 5th over 3c to the third, and all of that is to the 4th. Now if I distribute the exponent in, I get e to the 20th over 3 to the 4th, c to the 12th. 3 to the 4th is 81, so you could actually write it as e to the 20th over 81c to the 12th. Now in 34, list the steps we would use to simplify. What we should do first is we should flip the fraction to make negative 3 positive. Then we distribute. Actually, before we distribute, I'm going to reduce the 5 and the 10. So that's going to be 10 over 5, because I've flipped it. It's 10a to the 6th over 5a to the 8th. So I'm going to reduce 10 over 5 to 2, and a to the 6th over a to the 8th to 1 over a squared. So now it's 2 over a squared to the third. Next, I'm going to distribute the exponent. To the fraction. And I get 2 to the third and a to the 6th. And last, I'm going to do 2 to the third equals 8, and so my answer is 8 over a to the 6th. So on 35, we're looking at writing it in radical form. So anytime we have a value to the 1 over n, we could write that as the nth root of that value. So m to the 1/2 is the square root of m. You don't have to write the 2 there, because if we use that symbol, we are assuming that is a 2. For 36, I have 2/3 for the exponent of p. So that means I could put the 3 into radical and write p squared inside the third root. And then r, since it has a 5, is the 5th root of r to the 4th. So that denominator becomes the root. The numerator can stay in the fraction. For 37, I'm going to do 36 to the 1/2, which is the square root of 36. And I'm going to do the square root of x to the 4th. Now, the square root of 36 we know is 6. But back here, if I did 4 times 1/2, that just becomes x squared, which is also the square root of x to the 4th. We just get x squared. So 6x squared is our answer. It'd be a little maybe easier to distribute here and realize that that is equal to x to the 4/2, which is x squared. 38, I get the third root of 125 and the third root of x. The third root of 125 is 5, because 5 cubed is 125, so we'd write 5 cube root x. 64 to the 1/2 x to the 3/4. 64 to the 1/2, or the square root of 64, is 8. So we're going to do 8, and then the 4th root of x to the 3rd. For number 40, I'm going to do the 3rd root of 25. And then if I distribute in the exponents, x to the 2nd times 1/2 is x to the 1st. And then y is just y to the 1/2. So we're going to get the cube root of 25 x square root of y. Make sure you keep them separate. Be careful about how you write the root symbol. It should not be going over the x. For number 37, we have 27 to the 2/3. First thing we're going to do is make that 27 in the cube root, and then leave the squared there. The cube root of 27 is 3, which becomes 3 squared, and then 3 squared is 9. For number 38, it's the 4th root of 68 x to the 3rd, or 64 x to the 3rd. The 4th root of 64, 64 is 4 times 16, which is 4 times 4, and it doesn't look like it's going to simplify down, so we need to look at simplifying what else we got. So we actually have 6 2's, and because of the 6 2's, we can take a set of them out, which is going to leave 2 of them left. And then the cube root of x third is going to stay in as well, because we don't, or the x to the 3rd and the 4th root is going to stay in, because we can't simplify that. So this then becomes 2 times the 4th root of 4x to the 3rd. And that's really all we can do to that one. Now, in number 39, it takes this same problem and now says, well, what if it's to the 5/4? So we actually get the 4th root of 64x to the 3rd to the 5th, which we found out was 2 the 4th root of x, not the 4, x to the 3rd, now to the 5th. So from this one, I'm going to have 2 to the 5th. The 4th root, it's going to be 4 to the 5th, and x to the 3 times 5, because I can move that exponent from the outside inside to the radical. So now 2 to the 5th times, if I'm looking for the 4th root and I have 5 4's inside, I can take 1 out, leaving 1 4, and this is x to the 15th. So this is 2 to the 5th times 4. And I'm going to take out 3 sets of 4, so that's x to the 3rd. That leaves me with 3 on the inside, so we're going to call this 2 to the 5th times 4, x to the 3rd, 4th root of 4, x to the 3rd, which is quite a mouthful, but we're going to have 2 to the 5th is 32, times 4, that turns out to be 128, x to the 3rd, the 4th root of 4x to the 3rd. Okay, and now for number 40, I have 3 to the 1/3 and 3 to the 6/5. Since they are like bases, I'm going to add exponents. Think of it, if it was 3 to the 3rd times 3 to the 6th, you would just add 3 and 6. So I'm going to go 1/3 plus 6/5. My common denominator for those two are going to be to the 15th. So to make it to the 15th, I have to multiply top and bottom by 5. To make this to the 15th, I have to multiply top and bottom by 3. And so this comes out to be 3 to the 23rd 15th, which if we need to write in radical form, will be the 15th root of 3 to the 23rd, or the 15th root of 3 and the 23rd exponent on the outside. For 41, we need to write as a power with a rational exponent. So in the square root, so I could write them both like this, xy to the 1/2. You could also write it as x to the 1/2, y to the 1/2. 42, we're going to make that a to the 1/4 as your exponent. 43, it's going to be b to the 2/3, because that becomes your denominator, so it's already squared, so it's to the 2/3. For 44, we get x to the 6/3, y to the 9/3, which we can simplify both of them and get x squared, y cubed. They simplify the fractions. 45, we have the, let's separate these first. I have the 4th root of 81, and then x to the 2/4, because I want to look at that 4th root of 81. The 4th root of 81 is 3 times 3 times 3 times 3. It's 4 3s, so this actually becomes 3, and then the x to the 2/4 is x to the 1/2. 46, we get x to the 2/5 and y to the 3/5. Now, for 47, we're going to keep all of these have the same base, and what we're going to do is change them to exponential. So I get 81 to the 3/4 times 81 to the 6/4 equals 81 to the 2x. Because what I really want to look at is these exponents. This is really an equation solving for x hidden within the exponents. All the bases are the same. Now, it may be tempting to take that 81 and simplify it down to the 3, but I don't want to do that because I want to have all the bases the same. So now it's 3/4 plus 6/4 equals 2x. Well, this together gives me 9/4 equals 2x. I can multiply the 4 over, and I get 9 equals 8x, but actually I should have just divided over the 2, and I get 9 over 8 equals x. Same thing on 48. I'm going to have 3 to the 5/2. This becomes a 3 to the negative 3/4, because it becomes 3/4 due to the 4th root, and it's negative because it's in the denominator, equals 3 to the x/4. Now, taking the exponents, I get 5/2 minus 3/4 equals x/4. I'm going to change the first fraction to 10/4, so they have like denominators. And now I can even just look at the numerators. 10 minus 3 equals x. I'm going to get that x equals 7. For 49, we're going to get 7 to the 1/5 to the 1/3 equals 7 to the 1/x. So I'm going to multiply here. Be careful, don't make this 3/5 or 5/3. It's actually 7 to the 1/15 equals 7 to the 1x. We're really looking at denominators in the exponents, and x equals 15. Our last set here, let's simplify the statements and determine if it's rational or irrational. So if I do square root of 3 times square root of 7, I get the square root of 21. That is not a perfect square, it does not simplify down, so it is an irrational number. If I add the two, I can't combine them and make them the square root of 10, so that doesn't work either. It is also irrational. But on 52, it's a little bit different because the square root of 49 is 7, so now it's 4 plus 7, and I get 11, and that is a rational number. Now 4 times the square root of 47, 47 unfortunately does not simplify, so that is an irrational number. But if it was 4 times the square root of 49, we could have made it 4 times 7 and 28, and it would have worked. For 54, we're going to combine like terms. I have 3 root 5s and 2 root 5s, so I have 5 root 5. Unfortunately, that is still an irrational number. And for our last one here, I'm going to combine like terms. I have 4 minus 6, and I have 5 root 3 minus a negative 2 root 3. This becomes plus, so I get negative 2 plus 7 root 3, and it is also irrational.